My name is Chris Newland. I am a middle school science teacher, having taught 6th, 7th, and 8th grade at different points during my career. If you are watching this video, it probably means you were absent from school today when your class started an exciting new unit. And so I am here to help you follow along with what your class did that day so that you can keep up and be ready to go when you get back to school, hopefully tomorrow. To follow along today, you're going to need a few things. If you have a science notebook, that would be great. If you don't have a science notebook, you're going to need some paper or something to write on. You can always tape that into your science notebook later, so you don't have to rewrite anything. You're going to need a pencil or some other writing utensil, pen, whatever. Ideally, if you could also have 2 colored pencils, 2 different colored pens, 2 different colors, something. At one point, you're going to have to separate a few things out by color. And to make sure that your Chromebook is either plugged in or charged enough for about 45 minutes of time, which is how long this class is designated for. So if you need to go gather any of those things, just click pause in the video and go get them. And then when you come back, just restart the video. Great. Hopefully you were able to find everything you need. So we are going to get ourselves rolling with a little phenomena that I would be willing to bet that you are pretty familiar with. There is this scene, this picture on the left side of your screen, I hope is not too familiar to you, but if you're like most kids I've met, at some point or another it will be. And then going along with that, there's some interesting and sort of startling statistics about how many cell phones get broken every year. So Americans, on average, break 2 smartphone screens every second. That means in the 3 minutes times that we have started this, 360 cell phone screens have broken. That more than 50 million screens are cracked each year. Many, 95 million were damaged in the world by someone dropping them. We spend $3.4 billion each year replacing cracked screens, and that's not even counting apparently 38% of smartphone owners who don't bother to replace them at all, and they just buy a new phone. And 27% have said that their phone was in a phone case when they broke it. And all that information came out of an article in the Miami Herald, which is a newspaper. And to me, it just seems like a lot of cell phone damage happening. And this got me wondering, is this true for us too in our classroom? So have you actually ever experienced cell phone damage before? In class, we took a minute to turn and talk and share some of those stories out loud. And I know that you're at home, so you may not be able to do that. But if you have a chance, there's someone else in the house, or you have some friends that you could send a quick text message to or a snap, maybe ask them if they could share a story about a time where they broke a phone, or perhaps a family member has a story about that, or perhaps you have a story that you could share with them. So if you want to take a minute to find some cool stories out there about how people have broken their phones, go ahead and pause this video right here and maybe just jot down a couple of the ideas that you hear, and come on back in a minute or two when you have some interesting stories to share. All right, I hope we found a couple of interesting ones. My guess is you probably knew a couple of interesting ones anyway. And when we were in class, we got a little dramatic, and we used these old CD cases to represent a phone. And we actually reenacted some of the dramatic breaking moments of our phones. But I know that you probably don't have these at home. So I wanted to share with you some of the things that came up during the activity. One of the things that came up that was kind of interesting is that there was a lot of different ways in which phones got damaged. Um, so probably the most typical one, kind of looked like this. It was where the phone was moving, like being dropped or being thrown, and it collided with something that was not moving. And we kind of categorized this as a collision type A, and it was probably the most common one that we saw along the way. But it wasn't the only one. We also had some situations where the phone or object that was being damaged or not didn't move, and it was something else that collided with the phone. So that we labeled as kind of like situation B, and that would be, I think, the typical example was it being stepped on or something being dropped on top of it, which is a little different than situation A. And as we were chatting, we realized, well, there's actually a third possibility. One possibility was that the phone was moving and it hit something. A second possibility was that something was moving and it hits the phone. But there was a third sort of more rare option, which was that it would be possible that maybe both things were moving and that they would both collide instead of having just one of them being in motion. And so we kind of categorize these as type A collisions, type B collisions, and type C collisions. And this was a way for us to sort of organize the kinds of crashes and collisions that we were talking about in class with our phones and stuff. And one other thing that we did talk about was, it was, when we drew this out, we drew like the moving object here on the left. And then the thing that was the other object, like the ground or whatever, was on the right. But then we said, would it really matter if we kind of switched that around and we put one over here and the other over there? We decided it really didn't actually matter which orientation we drew it, whether it was left and right or right and left, as long as the idea of the movement was there. So there's a little something to think about. Is there's a few different ways that we thought collisions could happen. And then we said maybe if we're going to talk about collisions, that we should definitely have a definition of a collision. Like, what do we mean when we say collisions? And so we decided on this, which was a collision is simply when one or more moving objects hits or runs into another object. And you might want to take a moment right now to either jot down those 3 collision types and the definition into your science notebook. I suppose alternately you could take a screenshot of this slide, and that would give you all of that information, because we're going to loop back to that in a moment with when we talk about some related collisions beyond maybe just a cell phone, because cell phones are certainly not the only thing in the world that collides. So I'll pause here for 30 seconds or so to give you a chance to gather up all that information. Okay. These categories of collisions are really useful for thinking about how things collide. For example, our phone and things getting broken or shattered or damaged. But of course, there's also the reality that sometimes there's collisions and it doesn't seem like anything gets damaged at all, where there's no damage. Think for a minute about something other than a phone and examples where maybe you were noticed a phone or another object was not damaged in a collision. Or maybe that surprised you. Maybe it was one time you dropped it and it broke, and one time you dropped it and it didn't. And I want you to make a little list of collisions that you thought of. Except this time, as you think about your collisions, I'm going to have you color code them a little bit. So if you are listing a collision and that collision resulted in the damage of one or more of the objects, then choose one color pen or pencil to write that collision down with. But if you're thinking of a collision where it doesn't seem like something was damaged, just write it down in a different color. So I'm going to pause for a minute to give you 2 or 3 minutes to sort of collect a small list of collisions where damage occurred and collisions where damage did not occur. You can pause the video for as long as you need to make your list. But once you have your list, I'm going to ask you to look at each collision and do 2 things. The first of which is to identify the objects that came into contact with each other during a collision. We said a collision needed 2 objects, like the phone and the floor. So what are the 2 objects in the collisions that you wrote down? And second, if you could underline if one or more of the objects was moving. So let's say your collision was a tennis racket hitting a tennis ball. If the tennis ball was moving, then you would underline that. If the tennis racket was moving, you would underline that. If both were moving, then you would underline both. So I would suggest you pause the video here again for a few minutes while you look at each collision that you wrote down and underline the things that were moving. Okay. I thought you might like to also see a small sampling of things that your classmates came up with, of things that were moving or things that they had noticed that were collisions based on our definition. So here are a few that they shared. There were actually many, many, many more, but this is just what I could fit nicely on a slide. And these are color coded. They may not be using the same colors that you used, but the green ones were collisions that did not result in damage, and then the red ones were collisions that did result in damage. So falling out of a chair, bumping into someone in the hallway, a football tackle. Apparently someone threw a water balloon at their brother and it did not break. Or someone brought up kickball when your foot kicks the ball. Then there were some that did result in damage. The classic dropping of the Stanley or Hydro flask and it dented. Dropping an egg on the counter or the ground. Breaking a mirror. Dropping a glass or other dish. There was lots of dish breaking going on. And then lastly, there was a ball hitting a window at someone's house and broke the window. So if you were having a little bit of trouble, like coming up with some ideas, go ahead and pause the video again and write a few of these down and add them to your collection. We often get ideas from our fellow classmates, and we created a whole list together in class that you'll see up on the walls when you return, or as soon as you return. So take a minute if you need to, pause and write a few of these down so that you have them, some extra ones available to use. Okay, hopefully you have a full and interesting list of collisions to work from now. Um, and we are going to take a minute to think about our collisions. And were they, a little while ago, we created those categories. Category A, where the um, one object was moving and it collided with a stationary object. Category B, where the object that got damaged or not was was staying still, and the something hit it. And then, of course, option C, which was our category C, which was a moving object was damaged or wasn't damaged when it collided with another moving object. So, sort of the three different categories that are possible there. And think for a minute about what your collisions lie. Were they type A's, type B's, or type C's? And go ahead right now and put a little note next to each one, labeling it an A, a B, or a C. And I would go ahead and pause your video here until you have finished that task, and then go ahead and restart. So while we were in class, we took some time and we went to and gathered together in different parts of the room to see if we could figure out patterns that were happening in the different collision types. And so in your science notebook or on a piece of paper, let's group those collision types now. So what I mean by that is we'll create some boxes and we'll fill the boxes with the types of collisions that we brainstormed that fit that amount. So, for example, if make a box somewhere on your paper that says A, and then anything that was an A collision, write it inside of that box. Similarly, if you have some collisions that you labeled type B, go ahead and put those in the box. And if you have some collisions that you labeled type C, go ahead and make a third box for them. Once again, I suggest pausing the video here while you sort of group all your collision types together. Okay. This is going to be a bit of a think through for you. You could, if you wanted, if there was a brother or a sister, a family member, or a friend that you wanted to share this with and talk through it with them, you could do that. But if not, I think it's probably fine that you think this through on your own. So you have a group of collisions that you called type A, and a group of collisions you called type B, and a group of collisions you called type C. And what you're going to look for is, does there seem to be anything about a certain collision type that is a pattern or a similarity in how that collision and or damage or no damage occurred? So for this first part, I'm going to ask you to look at all of the collisions you wrote down that caused damage. Was there anything they had in common? Was there anything that made them similar to each other? Was there anything that stood out as unique or different? And if you found a similarity or a difference, to make a note of that. Then, after you've done that for collisions that cause damage, take a look at your collisions that did not cause damage. Is there a pattern in those? Was there something that seemed to be a reason why the collisions did not cause damage, and to make some notes about that. And in a few minutes, we'll create a little patterns chart in our science notebook and summarize all of those so that we have them to use while we explore colliding objects more. Hopefully, you found a whole bunch of patterns or similarities or differences, important factors, variables across these different types of collisions. And I want you to make sure you record these ideas. So as you look at this slide, it shows you a page in your notebook that's divided up into two halves. On the left side, it talks about patterns that you noticed in collisions, and those could be patterns in collisions that cause damage or patterns that occurred in collisions that did not cause damage. Maybe continue to use those two different colors as you write those patterns out so you can be sure you know which ones were which. And then on the right side, there is a column for factors or variables that sort of help figure out how some collisions end up or cause damage and some don't. Like, what are the things that matter in a collision as to whether something's going to get broken or damaged or hurt, and what might matter if it didn't. So this is definitely a place for you to pause the video as you create this T-chart in your notebook and write down any patterns you notice in collisions that cause or don't cause damage, and or what are the things that maybe help decide whether that damage gets caused or not. Okay, once again, I thought it might be useful for you to see some of the ideas that your classmates came up with for this. So I added a few of them here on the right side of the page. They thought things like the mass or size of the object might matter, how fast something was moving might matter, the direction the objects were moving, like were they moving towards each other, or were they moving in the same direction, or were they hitting at an angle? And there was a lot of discussion about the material the object was made out of. Well, if it was a soft thing versus a rigid, hard thing, did that really matter? So these are all ideas your classmates came up with, and you're welcome to pause and add any of these to your notebook now. So here's where we're going to try to make a model of what's happening when two things collide. And you don't have this handout at home, but if you take your notebook and you sort of turn it turn it sideways, you can recreate this in your science notebook. And there's a few bits and parts to it. So first of which is you get to choose, like, which collision that you thought of or looked at seems most interesting to you. And that's the one you're going to describe. And so on the very top line here, it says, which two objects were colliding. And you definitely want to make a note of that. It also asks you to match that with a collision type, A, B, or C. And then finally, was there any damage that was caused in that collision? So you're going to want to answer those questions in your science notebook now before you move on to those two boxes that are below. In the two boxes below, you have to sort of use your imagination a little bit and imagine you could slow time down, or that you could freeze or slow-mo or even pause a collision at different points in time. And the question is, what do you think you would see happening to the objects right at the moment that they first touch each other. That very instance where they're moving and they come together and they just touch. That's for the box labeled on the left, which is called time point 1. And then, what about just a tiny bit later, a split second later? And that's the box on the right. So you're going to want to pause this video here and draw and label or describe in words what you think you would see happening for both objects at each time point. So you have two things colliding, what happens when they first touch each other, and then what happens a split second later to both of the two objects. I think you're going to need to pause the video for 5 to 10 minutes right now to complete this. And simply replay the video for the last part of today's class when you're done drawing your model. Okay, last step for today. I want you to take a look at the model you just drew. And you'll see that in the slide that is here, there is a new handout, and that you'll have to type in the URL that you see up here in order to do that. Keeping in mind that the capital letters and the lowercase letters matter, so you have to type it in exactly as you see. And when you do that, you're going to come up on a handout that asks you to think about what's happening at the objects in between the time point 1 and time point 2. And time point 1 means that in your model where you just drew that left box, and what's happening in time point 2, the model that you drew in the right box. And they're asking for two things. First of which is, what do you think you would see happening between those two time points, the first point of contact and a split second later? And then the second is, there may be some things happening that you can't see. Maybe they're too small, maybe they're invisible, there's something going on that you just might not be able to see, but you think is happening. And it's okay to write those ideas too, because we might be able to explore them some. And then lastly, if you chose a collision that resulted in damage, how could that collision be changed to result in no damage? Or if you chose a collision that did not result in damage, what would you have to do to change the collision so that one or both of the objects became damaged? So kind of a fun thing to think about for the very end there. So there's those three parts of this model. What are things that you could see happening during a collision? What are things that you maybe can't see but think are happening? And finally, if you wanted to change the result of a collision, either from no damage to damage or damage to no damage, how could you do that? This is where we left off today. So as much of this as you can complete before coming back to school would be awesome. Don't worry about getting anything right or wrong. This is just a wonderful place to share your initial thoughts and ideas about what happens when objects collide. You can, of course, if you need to rewind or replay any parts of this video, you can do that at any time. And I hope this was helpful and will help keep you caught up in your class. Good luck. Hello and welcome. If you are watching this video, it likely means that you were absent from class at some point today or this week, and you need to have a little catching up to do. And that's what this video is intended to do. My name is Chris Newland. I'm a middle school science teacher, and I'm here to help you do that. As you can see on the slide, there's a few things you're going to need to participate in this lesson today. You hopefully have your science notebook, or if you don't, maybe just some paper that you can write on and tape into your science notebook later. You will definitely need a pencil or pen, Maybe a colored pencil or two would be a handy thing to have as well. There are two worksheets or papers that you created from the first class of this sequence. The first was something called the Initial Ideas Model. You created it in yesterday's class. It is the image that you see down in the bottom left corner of this slide, if you need a reminder of what it looks like. And if you just happen to need another copy because you're left it at school, it's in your science notebook, it's nowhere that you have, that's totally fine. You can use this bit.ly link to open a new one. Just keep in mind that in the bit.ly link, everything has to be typed exactly as you see. Capitals where capital, lowercase where lowercase. The second thing you need is the second handout you got yesterday. It's called Object Interactions During a Collision. It's the image in the bottom right corner of our screen. And again, if you just are like, I don't have it and I just need it so that I can do it right now real quick, go ahead and click the bit.ly link again, keeping in mind every capital and lowercase has to be typed exactly, and it will give you another copy. I suggest pause this video right here for a minute while you gather all your things, and once you have them, just restart the video and we'll get ourselves moving. Hopefully you were able to find everything. So sitting in front of you is your science notebook, your initial model objects during collisions paper, and your object interactions during a collision paper. If you were in class for this activity, you would actually have a chance to compare the model that you created and your object interactions during a collision paper. Wow, that's a mouthful. With a partner right now, and but you didn't have a chance to do that. So I have, and on the next slide, I put images from 3 student notebooks where they did the same exact modeling activity that you did. And as you look at them, I want you to think a little bit about, like, what do you see in those pictures that is similar to something that you put in your model? And if you found something that's similar, give it a little check mark. Make it stand out. You could highlight it, you could check mark it, circle it with a colored pencil so that you know that someone else had an idea kind of like yours. Also, if there were things that you thought affected collisions, like stuff that made them cause damage or not cause damage, go ahead and make a mark about that too. And then if you see something on your paper that was just unique and you're like, I'm the only one who thought of this, definitely put a little question mark next to it, thinking, because that's going to be something our whole class is going to want to think about. So I'm going to advance this slide. You'll have 3 different models to take a look at. I apologize, the writing's probably going to show up a little bit small, but you can always zoom in if you need to a little bit. And I suggest pausing at this next slide for a couple of minutes so that you can see what other people were thinking. And there's 3 collisions involved here. There's this collision up here at the top of the paper where they are talking about 2 cars that bump into each other. Not a hard collision, but just a bump. And then something that you may be familiar with. I know most people at one point or another have dropped a glass or a dish or something like that, and that broke. That's what that second one in the bottom left shows. And then this third individual was thinking sports, and they were showing you where a baseball bat and a baseball collide. So take a few minutes, pause this video right here, and look back at your own model. Notice places where you had a similar idea, places where you had a different idea, and go ahead and make some check marks and circles and highlights just to highlight those wonderful moments. Okay, hopefully you have had a chance to look at just these other models. And in class today, we decided we would gather up in a scientist circle and see if we could share ideas that we all agreed on. And we created a poster around that so that we could understand what our whole class was thinking. And everybody was free to share any idea they had. So I wish you had been there to share your ideas. I can't share every moment of that discussion with you. But what I can share with you is the final result. And so I'm going to advance a slide here and show you the poster that we created today. And what I'd like you to notice about that poster is that we kind of had to think about two different types of collisions. There's, of course, collisions that resulted in damage, and then there's some collisions that did not result in damage, right? Because not everything gets broken just because it touches. And we had a hard time figuring out like what we really wanted to include here. So let me just highlight a couple of key moments and features for you. One of which is that very first column, that time point 1, when the moment of impact where they touch each other. And we talked about a lot of things, like would we see anything actually happen at that moment? And in the end, we came to the conclusion that all we would see was them touching. That they weren't bending or breaking or shattering or bouncing off at this point, that they just touch each other. And that was something that almost everybody had. And then we talked about, well, what changed, what would we see at the end of the collision, like that split, that time point later. And that's over here all the way on the right side of the poster. And you're going to see there's a lot of question marks there. Like, we had a conversation about, if something is damaged, is it always permanent? Like, are there things that get damaged that can get fixed again, and therefore they aren't damaged, or were they ever damaged in the first place? We talked about things that would break. We talked about things that would shatter. We talked about maybe there were things in there that we couldn't tell at all about molecules. And then there was, of course, when you had a collision that there was no damage, we decided that we would just call that not permanent. Like, it was something that could be fixed. It would like rebound back. And that often that might happen where something bounced off of something else. So that was kind of like a lot of question marks for us. We had a lot of wonderings about what damage meant as a word. We had a lot of wonderings about like what permanent versus non-permanent was. We had like, is breaking and denting a same thing? And that's where those things in the center come in. Like, what would we actually think we could see when these things collided? So do we see their shape change? Did we see them dent? Did we see them bend? Did we see them change directions? There's all kinds of different things that were found in there. And I'm going to share with you one more that's a little bit more cleaned up. So this came and we kind of like put everything into an electronic format, so it'd be a little bit easier to read. But hopefully you're noticing that there's some of those same ideas found in there. There's damage, there's breaking into pieces, bouncing back, permanent damage versus non-permanent damage, the touching at the beginning. So there's a whole bunch of things our class talked about. And just like a minute ago when you looked at those individual models, if there's anything on here that matches up with what you drew and what you talked about in your model, go ahead and pause the video right now so that you can highlight those and know that your ideas are included in our classroom model. And when you get back to school, that's going to be up on a wall somewhere for you to see, and you can go over there and just take a look at it. So pause for a minute, see where you had things that agreed with what was on here, and restart as soon as you're ready. Okay, you're going to need to create a new page now in your science notebook. And the title of that page is going to be Initial Collisions Questions. So we've been talking about collisions in class for a couple of days now, and there were a bunch of places in our models and in our ideas that we weren't sure about. So you're going to notice this says to look at the consensus model for collisions poster. That was this one that you saw here a minute ago, or this one right here. So you might have to rewind a little bit if you want to revisit those two models. And it asks you to think about what new questions you might have about the objects in a collision and the changes that might happen to them during the collision. And on this page in your notebook, you're going to write 2 or 3 questions about that. Keeping in mind, these could be questions about the collision that you modeled for yourself. They could be a collision from some of those related collisions, those A, B, and C type collisions that we talked about yesterday. They could be a brand new collision that you just thought of because of some of the things you saw today. But pause the video here, take a minute or two to write down 2 or 3 questions, and it could be about a collision that causes damage, or it could be about a collision that didn't cause damage. So go ahead and pause here while you write your questions. Okay. Now we've got models, we've got ideas, we've got questions, and a little while ago you were asked to jot down some notes of things that you thought were patterns in collisions, or things that, factors, variables, things that might make a collision worse or better. Worse meaning, I suppose, causing more damage, and better meaning causing less damage. And to think a little bit about how important certain things are during a collision. And you have that list in your science notebook right now. But our class today also talked about our lists and all of our different ideas about things that might affect a collision. So I'm going to share with you the list that our class created. And if there's any new ideas that you didn't have before that you want to jot down, that would be awesome. And if you have an idea that you want to add to this list when you get back to school, you should let your teacher know that. And they will add your idea to this list as well. So take a quick look at what the class came up with. On the left, it shares some of the common things we think, like you have to have 2 or more things and they have to touch. One of those things has to be moving. If the 2 objects aren't moving, then there isn't going to be much of a collision. And that in every collision, something changes, like even if we can't see it. And then on the right, the things that people thought were important include what the objects are made out of, whether it was fragile or not fragile, movement. In other words, were they both moving? Was one moving? How fast were they moving? How far away were they when they started moving? That's what the distance word is there. Were they something that had some protection, like to shield them from the other object? And then you can see a whole bunch of other things there, including whether they were bigger, they were more dense, they were more compact, how long the collision took to happen, the angle, like did they come together and hit head on, or were they coming at an angle and bouncing off? So these were all things that our class chatted about. And this was the last thing that we did in class today. So if you want to take a moment to pause the video and update your factors and variables chart, please do that. And know that this is also where we're going to pick up when we come back to class tomorrow. Hope this video has been helpful and that you feel caught up. And I'm sure your teacher looks forward to you coming back to school tomorrow. Hello and welcome. If you are watching this video, it is probably because you were absent from school on today or a day recently, and this video is here to help you catch up on what we did while you were not in class. My name is Chris Newland, and I am a middle school science teacher, and here to help you get caught up. You're going to need a couple things For this session, it's you're going to need your science notebook, or at least some kind of paper to write on. You can always, tape it into your science notebook later, or whatever you need. You are going to need a pencil or a pen, something to write with. Um, Maybe even a marker would be a good idea today. And then I don't know if you happen to have any sticky notes handy or lying around, but if you did, they would be helpful. And if not, your teacher will certainly have some for you when you get back to class tomorrow, or whenever you make it back and are feeling well. If you want to pause the video here for a second to gather up the things that you're going to need, go ahead and do that. And if not, we will move right ahead. So, in our last class, where we left off was we were making a chart. And that chart talked about, like, what are things we noticed that were the same patterns in collisions that cause damage or collisions that didn't cause damage. And then also, like, what were some of the things that were responsible for that? What are some of the factors or some of the variables that might create damage in a collision versus not? And we created a list around that in your science notebook, or if you were absent that day, on a separate sheet of paper. But that list looks something like this. And if there is anything that you want to add to this list at that point, now would be a good time to do that. The other thing you might do is take a look at your list in your notebook, or the list on the screen here, and say, did you think that one of these things was more influential in a collision? Like, was something here more important than something else? And if it is, maybe star it or underline it so that you have an idea of something that you personally think is more important. Of the different things that you see there. So you should pause once again this video for just a moment to make any extra notes that you want to add, or anything that you think is a factor or a variable, a pattern, and then to underline or star ones that you think are more important. So take a moment, pause the video here, and go ahead and mark up your list. Okay. So your class today, most likely, decided that with all of the things that we've talked about with regards to collisions, that we should record some questions that we have had, or that you individually have had, about collisions. There are a lot of things that you can look back at to help you generate those questions. You have initial questions on a notebook page. You have your factors and variable posters. You could ask a question about those. You could ask how or why questions about what goes on during a collision. You might want to ask a question about changes that occur during collisions. There's many, many possibilities of places to draw questions from. So once again, I am going to ask you to pause this video for 2 or 3 minutes. This is that time. If you had a couple of sticky notes, that would be fantastic. You're going to notice on the slide itself that these look like they were kind of written in little sticky notes. And the trick to this is, if you have sticky notes, just write one question on each sticky note. Don't try to squish them all into one. If you don't have that, you can simply make a list in your science notebook of 2 or 3 questions that come to mind, and we can add them to the driving question board once you get back to class. So take a couple minutes, pause the video, write a question or 2, maybe 3. You can actually write as many as you want. There's no limit. Questions are questions. And start the video back up again as soon as you are ready. If you were in class with us today, you would have done this. We actually decided we were going to share every question we had as a big class all together. And we did it in turns. So one person would ask a question, and then they would stick it onto a board, and then everybody else who was listening, they kind of said, "Oh, I have a question that's connected to that," and they shared their connections. And I don't have the board that was created in your class, but I do have a couple examples of boards that were created in other classes. And I'm going to share those with you. You should feel free to pause and zoom in on them to see the types of questions that other students were asking. Um, and keeping in mind that your questions are really important. And what we do in the future is going to be related to your questions. So when you get back to class today, tomorrow, or whenever you are ready, make sure that you share your questions with your teacher so they can get added to our class or group list. But here's a couple examples from other classes. Okay. I don't know, you may have to zoom in a little bit to read some of these, but I can share a few of them with you for sure. They are things like, what about raindrops? I thought that was an interesting question. Like, is a raindrop falling on the ground or on you a collision? Do all collisions result in changes? Does speed matter, or does heaviness matter? Do things sometimes just get lucky and not break, or is there more to it than that? Can you break a rock? Like, and why don't all rocks break the same? There's all kinds of interesting questions that came up about uh, the things, the types of collisions that we all chatted about in class. Here's the second driving question board, another one for you to look at. And once again, if you wanted to pause and look at it more closely, you of course can. Do the materials make a difference in braking? Is speed the main factor in collisions? What happens to make things change shape? What happens at the particle level, like deep down with those atoms and molecules? How much force do you need to break something? How does the distance an object falls affect the breakage of the object? So these were all different types of questions that were asked by students in other classes, and maybe they've even helped you, think of a few questions for yourself that you could write down. Okay. Of course, if we have questions, we are definitely going to want to figure out how to answer those questions. And that was our last step in our class today. And this is where I'd like you to create a new page in your science notebook. And that title of that page will be Ideas for Future Investigations, like experiments, and data information that we might need. And on that page, once again, I'm going to ask you to pause our video and write a couple ideas of things you might like to do to try to answer some of the questions that you saw, or maybe just some of the questions that you had. Personally, as we were thinking through all the different collisions we've been chatting about in class, or as you've been following along with our video series. So go ahead and pause this video here, create this page. If you don't have your notebook with you, create it on a piece of paper that you can cut and tape into your notebook later, or glue or whatever, however you like to do it. And write a couple ideas for investigations that you would love to do, or things you would like to do to try to answer your questions. Like before, I want to share with you some ideas that came from other classes, and I have a small list for you to look at. So let's see how this played out with other people. This is a list that came from a group of folks, and their first idea, and it was nearly universal, was if we're going to investigate collisions, we should probably break some stuff. Find some things we can break and study that. They wanted to investigate what were known as brittle things. Is dropping things the same as smashing things? What happens if things collide at different angles, head-on or corners or 45-degree angles? How about high-speed and low-speed collisions? Someone wanted to throw light and heavy things at walls. I'm not so sure about that one, but hey, why not? Using slow motion video so we could see collisions better. They wanted to alter the mass of things, like make a big thing hit a small thing, or a small thing hit a big thing. There was a lot of interest in humans and like how we get damaged during collisions, and how maybe you can make something into a different shape to protect it better from a collision. Anyway, and to change up the materials, like what things were made out of. So these were all ideas of things people wanted to do to try to understand collisions better. And with your ideas, which you should bring to your teacher when you return to class, and some of the ideas like this, I think we have definitely a plan to move forward with. And our questions tell us what we want to be able to figure out. Our ideas from investigations tell us how we're going to figure it out. And so I hope that you're as excited as I am for us to just start investigating all these things together and figure out why things break sometimes and why sometimes they don't. Have a great day, and we'll see you in class soon.